All right, currently you're watching video E4-p2.7, which is activity 12, cloud in a jar. All right, what I'm going to have you do to start off this activity is actually watch a very short video that comes from a meteorologist explaining exactly how clouds form. So the very first thing while watching the video, you're going to answer the actual pre-lab questions in the space below. So what you're going to do while watching it is exactly as it asks. While watching the portion of the video with the meteorologist, explain how a cloud forms in the space below. Again, if you want to draw a diagram to explain how clouds form as he's explaining it, you're more than welcome to. But again, the whole purpose is to better understand how clouds do form, or the formation of clouds, how that takes place. All right, so let's start off by watching that video with the meteorologist.
Hello. Today we're talking about how clouds form. Now, there's always moisture in the air. We call it humidity a lot of times, but it's water vapor. That's just water in its gaseous state. And it's invisible, but there's water vapor in the air always. Now, here's how a cloud forms. Once you start to have a rising parcel of air, as it rises, it cools. And as it cools, that gets down to the dew point. And once it reaches the dew point, that gaseous state of liquid will immediately change into a liquid state. It will form, it will go from a gas to a liquid. And when that happens, you get tiny, tiny drops of water, and that is what makes up a cloud. So again, the process is as you have rising air, that parcel of air cools. As it cools, it reaches the dew point, and immediately when it reaches the dew point, the moisture in the air goes from a gas to a liquid, or in other words, goes from water vapor to a liquid to the clouds.
Clouds are actually formed with just a really quick snippet, kind of with the diagram that he used to explain how the moisture itself is always rising, and as it starts to cool, it reaches its dew point, and that helps to form the condensation, which then helps to make the clouds. So what we're going to do is we're going to take that short little explanation about cloud formation and turn it into an actual lab where you can see that actually physically take place, how clouds form under different conditions. All right, so the materials that are going to be listed in just a moment for you, you're going to find from either myself or Mr. Fusak, and I would like for you to go grab those materials right now, and here's the list that you need. All right, now that you've gathered your materials, we're going to start by having you read the background information, which is found on page 127. The background information is literally the second page. It'll come up and it'll look just like this. And what it's going to do is just kind of give you a brief synopsis about the different types of clouds and how clouds get their name and those sorts of things. It's nothing of huge importance, but nonetheless, it's, again, just some background knowledge about clouds. Okay, once you've done that, I'm going to ask for you to actually go through and now begin to read the procedures before even starting the lab. The reason, again, is just making sure that you have an understanding of what it is you're doing before you actually do it, so that you don't make the mistake while actually doing the lab and then have to start the entire process all over again. So while you're working, after you've read the background information, you're going to then turn the page and you'll see the list of procedures here, starting with 1 all the way through and even going on to the next page. But nonetheless, you'll see the procedures, and I'd just like you to spend just a few minutes reading through those to make sure that you have a good understanding of what it is you're going to be asked to do before you do it. Now, once you've done that, you're going to then reread and then begin following the procedures on page 128. The procedures are, again, pretty self-explanatory. They're nothing too complicated, especially since you're dealing with just some ice and some water, both warm and cold. But you'll notice right here, as you start to go through the procedures, it's going to ask for you to start to record your data and observations. If you notice on the very last page, here are your observations. Hot water and ice, you'll write what it is you saw happen, take place, and those sorts of things. And then hot water with no ice. Cold water and ice, and then cold water with no ice. Then the last two are match and aerosol. For safety concerns, Mr. Fuzak and I decided that it would be best if we were to demonstrate both the match portion and also the aerosol portion of this actual lab. So what we're going to do is we'll do that for you in just a few minutes on this video, and what you can do is you can start to record your observations as to what you see taking place when we demonstrate both the match and the aerosol for you. The other ones that are listed up here above are going to be trials that you will do, and you will record your observations as you go along with it. All right, so what I'll do is I'll hit pause on my end, and I'll set up the match and the aerosol demonstration and come back, and then we'll show you what those look like. So what you're observing at this point is when the match is dropped into the water, the smoke that is released acts as condensation nuclei. The condensation nuclei is what the moisture grabs onto, which is in the air, the water vapor inside of the actual glass, and that's what helps to form the cloud. And as you watch real carefully, you can see movement inside as the material warms and also cools, so you see really truly what is convection in its truest form taking place. And once the lid is removed, you can see that condensation nuclei that help to form the cloud as it starts to escape as the warm air rises out of the actual glass now that the ice has been removed. So this is the example of the aerosol that has been sprayed with no water and just the ice. And as you can see, as the aerosol begins to rise, it then contacts or comes in contact with the ice, which is starting to cool the actual air inside of it. And because of that change in temperature, it's creating, as you can see, it's creating this condensation as well as the condensation nuclei that allows for the cloud to be formed, and that's what you can see continuing to move up and down inside of the actual jar. As your procedure states, we're going to observe this for 3 minutes just to see what takes place over the course of that time span. one of the things you may have noticed over the course of this time is it becomes a little bit easier to actually see the condensation and then eventually the cloud inside of the jar being formed, especially as you look at the movement that's taking place right particular in this area here. It's a little bit more evident, a little bit more obvious, and partially because of the cooling that's taking place. More of the material itself is condensing as that warm air that's at the bottom of the jar continues to rise. And the aerosol is acting again as the condensation nuclei that is allowing the moisture to physically grab onto it. Okay, write down your observations. It's been roughly about 3 minutes. Alright, now that you've seen the two observations, the first being the one with the match and then the second being the one with the aerosol, your observation should be written in the space that you see provided here. Your observations, as you should for all of these trials, should talk about what it is you saw happen, what took place from the beginning, in the middle, and the end, talking about what physical features you actually saw forming, such as clouds, how quickly or how slow they formed, where did they form, near the top or the bottom, why did they form near the top or the bottom, talking about things like hot air, cold air, and when it's condensing and forming condensation or dew, in that being the form of a cloud. But nonetheless, now that we've got the match and the aerosol and you've recorded your observations in these spaces here, now it's time to go back and do the beginning of the lab, which is with the hot water and ice all the way down to here. So these 4 areas listed right on this side here, those 4. Where you'll find that is scrolling back here, right at the very beginning with procedures, talking about the things that need to be done. Filling the jar with hot water, let it sit for a minute, so on and so forth. And you'll do steps 1 through 5. Those steps 1 through 5 will be the ones that you'll have to do. The ones that I did for you in your observations were step 6, A, B, C, and D were the ones that I completed and finished for you. Okay, so you'll make your observations for that. Once you're done with your observations for each of those 4 trials, you'll then wrap up by answering the questions and the conclusions found on this page right here, 129, questions 1 through 8, right there. And if you would like, you're more than welcome to write your answers right here on the paper where there's space provided down here in the bottom, or if you want a separate sheet of paper, you can do that as well. Alright, should you have any questions or need any assistance or materials while working on the lab, do not hesitate to find Fuzak or myself. Thanks.